Hello everyone, my name is Haruki Ishizaki from Hiroshima City University. This time I'm going to talk about on the loop suppression method by utilizing information of master terminals for neighboring terminals in Bluetooth MANETS. Let's begin. I will mention the research background. This slide shows MANETS. MANETS consist of mobile terminals only without any communication infrastructure. In MANETS, terminals send data packets to terminals that can communication directly. When a communication infrastructure breaks down due to a disaster, MANETs are a prospective network technology for disaster response. Next, Bluetooth is a connection-based communication standard. Compared with other wireless communication standards such as Wi-Fi, it is characterized by low power consumption, high resilient-to-radio interference, and high confidentiality. In Bluetooth, two different standards exist. Classic Bluetooth is a conventional standard, in short, Classic. Bluetooth Low Energy is standard added from Bluetooth version 4, in short, BLE. The network constructed by using Bluetooth to communicate directly between mobile terminals is called a Bluetooth MANET. A terminal establishes a connection to communicate with others, and Bluetooth builds a small network called a piconet. The next slide shows the process of building a piconet. First, each terminal establishes an autonomous, distributed connection to communicate. The next step is to establish connection between terminals to form a star network called a piconet. Look at this picture. The group surrounded by dotted lines represents the piconet. The relationship between terminals that have established a connection is called master and slave. And a piconet consists of one master and several slaves. Furthermore, it establishes connections among piconets. The network called scatternet is constructed. Look at this picture. The group surrounded by blue lines is scatternet. As described, above we construct a Bluetooth MANET. When constructing a scatternet as shown in this picture, two new piconets are built by connecting piconets. Terminal A belongs to two piconets, one with terminal B and the other with terminal C. Thus, terminal A becomes the master in the piconet with terminal B and the slave in the piconet with terminal C. There are terminals that have multiple roles as master and slave. Recently, we have been researching Bluetooth MANETs, which consist of Bluetooth-enabled terminals. A connection must be established in advance when two terminals communicate with each other using Bluetooth. Therefore, we propose a combination method of Classic and BLE to establish a connection between terminals quickly. This is called the existing method. The connectivity between terminals using the existing method is significantly improved compared to simply using Bluetooth. Since Bluetooth MANET is designed for one-to-many communication, it distributes information to all terminals that have established a connection by routing. Next, I will explain the challenges of the existing method. The existing method was applied to sparse networks to establish connections quickly. Investigated the behavior of the existing method in large and dense network environments using a simulator. Look at this picture. In this picture, we form a piconet with terminal A as the master. It turns out that in a dense network, connections are formed more than necessary by the existing method. In this picture, in the piconet with A as the master, there is an unnecessary loop shown by the red line. Why is loop formed by the existing method will be explained in detail later. Bluetooth MANET diffuse data packets to all terminals by flattening. In this picture, the loops are shown as red lines. Flattening with the loops will increase the amount of extra data packets. The increase in the amount of data packets increases the processing load on the terminals, and this is the power consumption increase. We have confirmed that when a network has many loops using the existing method on an Android device, the application and Bluetooth operation becomes unstable, and the application is forced to terminate. For this reason, in the Bluetooth MANET research, the issue is that the amount of extra data packets increases due to the formation of loops when terminals are dense. Therefore, this study aims to suppress the generation of loops. From this slide, I will explain in detail the Bluetooth MANET constructed by the existing method. Existing methods do not have a mechanism to stop extra connections from being established. As a result, in the interior of a piconet with terminal A as the master, a piconet with terminal B as the master, and a piconet with terminal C as the master are formed. Unnecessary connections formed here are the loops. In a dense terminal environment, the number of piconets increases, the number of loops increase rapidly. Firstly, I reviewed how Bluetooth MANETs using the existing method can be used to connect. Look at this picture. Assume that terminal A to D exist within the connection range of each other. As shown in this picture, it periodically broadcasts the advertising packets containing public device address, as shown by the orange line. A public device address in an advertising packet is an address that is uniquely assigned to device that use Bluetooth, in short, PDA. First, when terminal A receives an advertising packet, it compares the PDA of terminal A with the PDA in the advertising packet, and if the PDA is larger than source terminal, it sends a connection request. Next, since the PDA of terminal A is larger than that of terminals B to D, terminal A sends a connection request to terminals B to D. Therefore, terminal A forms the first piconet of the master. Here, the terminal that sends the connection request becomes the master, and the one that accepts the request becomes the slave. Suppose the piconet with A as the master has already been formed. Next, terminal B discovers terminal C and D by receiving an advertising packet. The PDA of terminal B is larger than that of terminals B, C, and D. Therefore, terminal B sends a connection request to terminals C and D. Therefore, terminals B forms the second piconet of the master. In the same way, by establishing a connection between terminals C and D, a third piconet with terminal C as the master is formed. In this way, loops are formed by the existing method. From this slide, I will explain our proposed method. The purpose of our proposed method is to suppress generation of loops. Our proposed method prevents slave terminals from establishing connections to each other when they belong to same piconet. Therefore, in our proposed method, we include up to 2 masters PDA of piconets to which a terminal that sends an advertising packet belongs. This picture shows the information to be included in the advertising packet. If terminals belong to same piconet, they can already communicate in a piconet. So there is no need to establish a new connection. Therefore, do not send a connection request if terminals belong to same piconet. The picture on the left shows the topology that can be constructed using the existing method. The picture on the right shows the topology in which the loops is suppressed in our proposed method. From this slide, I will explain an example of Bluetooth MANETS using our proposed method. In this picture, terminals B to D belong to a piconet in which terminal A is the master. Terminal B receives advertising packet from terminals C and D and discovers terminals C and D. Terminals B, C, and D belong to same piconet, but they are trying to establish a connection between BC and BD. In our proposed method, I include the public device address of the terminal that sends the advertising packet. The information in this advertising packet indicates that terminal A is the master of the piconet to which terminal C and D belong. It turns out that the master of the piconet to which terminal B belongs is the same as the master of the piconet to which terminal C and D belong. Terminal B does not send a connection request because the advertising packet reveals that terminal B to D belongs to same piconet. The red line in the left picture shows a loop. The above connection control suppresses the loops between terminals BC, BD, and CD, and constructs an ideal topology as shown in the picture on the right. In this slide, I will explain the possible side effects of our proposed method. The side effects of suppressing loops are that diffuse of data packets to all devices may be slow, and data packets may not reach terminals due to isolation of terminals. These possibilities were confirmed by evaluation experiments. From this slide, I will explain the evaluation experiment. In this experiment, we implemented our proposed method on a simulator and evaluated its impact on the loop reduction and data packet transfer. These three items were evaluated. The following slide explains each of the evaluation items. We will explain the proportion of piconets with loops. A piconet with loops refers to a piconet that has an internal loops because the connections exist between slave terminals in a piconet. The proportion of piconet with loops is the proportion of piconet with loops compared to the number of piconets in the field. The number of data packet transmissions is the average of number of times each terminal has transmissions of data packets. The dissemination of data packets is the average number of packets received by each terminal in the field during the simulation time out of total number of data packets generated. Look at this table. This shows the experimental parameters. In this graph, the vertical axis is the proportion of piconet with loops, and the horizontal axis is the simulation time. The blue line refers to existing method, and the red line refers to our proposed method. The proportion of piconet with loops is measured at 10-second intervals during the 300-second simulation time. As a result, the proportion of piconet with loops decreased the most at 20 seconds of simulation time. The proportion of piconet with loops was reduced up to 10% with a simulation time of 300 seconds. Next, we confirmed whether the proportion of piconet with loops could be reduced by increasing the number of PDA in advertising packet by up to 4. This method is called our proposed method version 2 and is indicated by green line in this graph. As a result, our proposed method version 2 was able to reduce the proportion of piconet with loops more than our proposed method. This slide shows the results of number of data packet transmissions. I investigated to what extent we can reduce the number of data packets transmissions by reducing the number of loops. Look at this graph. Our proposed method reduces the number of data packets transmissions by about 210 times compared to the existing method by reducing the loops. Therefore, the traffic in the network can be reduced, which reduces the processing load on the terminals. Finally, since the side effect of reducing the number of routes is that data packets meant to be delivered, we next investigated the data packets dissemination rate. In this graph, the vertical axis shows the data packets dissemination rate, and the horizontal axis shows the simulation time. The blue line shows the existing method, and the red line shows our proposed method. As a result, with a simulation time of 45 seconds, the data packet dissemination rate is almost 100% for each method. In addition, we were able to keep the time to complete the dissemination of data packets at the same level as the existing method. Initially, there were isolated terminals, but over time, the isolation is resolved when the path is reduced. To sum up today's talk, we proposed a method to control the connection establishment between slave terminals and reduce the number of loops. The result of simulation experiments show that our proposed method suppresses generation of loops and reduces the amount of data packets, thereby confirming the effectiveness of our proposed method. Thank you so much for kind attention.